Hi and welcome to this video about Agamotto, Unity tool to control objects over time. So I will make a fast presentation of the tool structure and then we'll go through all the demo projects that are shipped with the assets. So first, how is it working? The most important thing to understand is that you need a time stone. This is the component that will control your time agents, which are the objects that you want to persist in time, and it will handle the simulation or the recording of these agents. This is where you will configure your simulation, your recording, and in editor you also have a controller, so you can directly manipulate the timeline, start simulations, and start recording. So you absolutely need a time stone. And then you get, as I said, the time agents here. The spheres, or as it's a physics simulation, the ground or the boxes. All those items that we want to persist in time, they need the time agent component. This is the component where you will decide which data must be persisted in time. And this is also where you'll use the Unity events to simulate code or persist your own custom data if you need. Like for if you've got a character with life or with mana points, you need to persist this data in time if you want to rewind or simulate them and move them in the future. So now for the demo, the first one is the simple physics demo. This is the most simple demo. This is just 3 spheres that are falling, and the physics simulation is made by Agamotto. So if I run, we can see here that the simulation has been made, and we can see their path that is simulated. The path is drawn using the path visualizer. This is a component in Agamotto that uses the timestone data and display this data using a line renderer component. So here I can unfreeze my object, freeze, resimulate, and I can go in the timestone and move the timeline or play back my simulation or play back backward if I want. And of course I can also start recording. I unfreeze them, and you can see now that the path is drawn over time with a limitation because the record duration is 5 seconds maximum. So if I stop, I can move my objects still over the timeline. So this is very basic physics simulation. Now I've got another demo that is a more complex physics simulation. Here we've got more objects, more collision, but this is basically the same scene. And you can see that the simulation is going fast, and if I unfreeze, all the objects are accurately following the path that was drawn. I can freeze, and of course I can still go and go play and do new simulations and play back at the speed I want. So the next simulation is more complex and more like a game. That's the pool simulation. This is a simulation where we're gonna simulate that we hit this ball, or you can select another, but we hit this ball and we see the path of every ball. When you shoot, you can see that it's going where it was drawn. So you can select, change, and change the force. Here it's good to see that, or it's important to notice that even the fails in the physics simulation are accurately simulated by Agamotto. Here the ball shouldn't go over because it's going through the wall, but if we shoot, the simulation is wrong and is doing that. So you can see that what you have in Agamotto is what you will have in the real physics simulation. Now, the next is the particle demo. Here, this is a demonstration of using Agamotto to simulate particles. So nothing happened here, but there was a simulation, and we can see here that we can go through the timeline because we simulated 10 seconds. Of course, we can set at start and start recording instead. I unfreeze them. I stop recording, and now I can navigate in my record. The next demonstration is about using Agamotto to simulate code and to record and simulate animator states. Here we have two objects, two characters. The first one is going through waypoints using code. The character is going forward but looking at the waypoint iteratively. And the second character is following the first one through code. And we've got an animation of run on both characters. If I stop, I simulate the next 20 seconds of the game. So I can start, simulate, stop in the middle, and we've got the simulation that is drawn. And every time, of course, you can go and use the in-editor controller to manipulate the timeline. So this is important to see that the animator state is recorded and you've got the animation right in the simulation. The next demo is the most fun one. This is the sorcerer demo. This is a little FPS where you can grab and throw cubes. And if I press the right click, I stop time and simulate what's going in the future. And now I can move in time. So of course, this is way more interesting if I destroy this. There, I stopped it before, but you can see what's going to happen. So to make the move in the timeline, here we use the playback system of the time stone, which allows to move in time and control the timeline, replay the data at the speed that you want. The next demo is the most complex one. This is the tower defense demo. The tower defense demo is the most complex demo that is shipped with Agamotto. This is mixing code simulation and physics simulation. We've got a very small tower defense game where minions are spawned here and try to reach this point while being shot by towers. So if I run, here are the minions and they must go here, and we have here the results, how many minions killed and how many reached the end. And now I can spawn towers, and the towers are spawning projectiles that are physics driven, and when they hit the ground they are doing some area damage. So here we've just run the normal game executing classic code, but we can simulate the same code, and here the interest is that we can run it at the speed we want. And of course, again, navigate in it and replay it if you want, as we want. So this is definitely the demo that you want to go and look at if you're gonna use Agamotto for some complex cases, because this is the most advanced demo. So thanks for watching.